Hello and most welcome to this tutorial. Today we will discuss about the central difference method and some related information about the time history analysis. After that we will have more information about this table and how to calculate each and every step for the central difference method. So let us first look at one of the example. For example, we will have use of central difference method and conducting the time history analysis of a single degree of freedom system under the earthquake acceleration record in Excel. So the earthquake record will be taken from one of the earthquake database, so which I have already taken. If you do not know how to extract earthquake records from one of the database, watch another tutorial which link is in the description box below. First, choose the stiffness, mass, damping ratio. This is the damping ratio, time increment or the time difference as given, like it will be given or we will choose it, and initial displacement will be 0 and initial velocity will be also 0. Okay, if other things are given, it is okay. And the next step, calculate natural period Tn, natural frequency omega n, damping constant C, also other constants which is A, B, or this is the stiffness constant in the others. All the data is inserted to Excel program by following the related formula. For each step has been applied as shown in Excel sheet. Okay, so we will show here in this Excel sheet. It is the central difference method. First, we will have some inputs. For example, mass is given, stiffness, and natural period, as I have told before, the damping ratio or percentage, the time increment or the time difference, displacement is 0, velocity is 0, and we will have total 2999 points, which is from earthquake records. This is the inputs. So after that we will calculate some the related steps which is for the central difference method. First we will calculate omega n or natural frequency, which is this formula, mass by stiffness under root. Mass by stiffness under root, so which I have already calculated in this Excel sheet. So afterward we will have constant, so then we will have the damping constant C. This is the value which I have already calculated. You can look here, this is the natural frequency, stiffness by mass under root. Also from this formula, this is the natural frequency, and this is the damping ratio is equal to C, that damping constant, by 2 multiplied by mass into stiffness under root. So from this formula we will calculate the damping constant C, from which you are able to calculate the damping constant. This is the exact formula and this is the natural frequency. So we will calculate the damping constant by following that formula which I have shown you. So this is the damping constant which I have calculated. So this is the damping constant which I have calculated from following this formula. From this formula we will calculate the damping constant and we will put all the given values. Okay, after that we will have the accelerations, initial acceleration which is 0, and also the displacement is 0, and also constant, stiffness constant is we will calculate from another formula. So we will calculate the stiffness constant by following this formula. This stiffness constant is equal to mass by time difference square plus this damping constant by 2 multiplied by time difference, for which you are able to calculate the stiffness constant. We have all these values which are in the formula. So this is the stiffness constant and this is other constants. So also these two constants you are able to calculate from these two formula is equal to mass by the time difference square minus that damping constant by 2 multiplied by time difference, and also B, it is stiffness minus 2 multiplied by mass by divided by the time difference square. This is the 2 constant, this is the stiffness constant, and the K is stiffness. Is just stiffness which are given here, this 1500, it is the stiffness, but K, like showing here, that is the stiffness constant, that is the difference. So make sure that you know the difference. This is the real stiffness, and the K just showing above it, that is the stiffness constant. So we have already calculated these things and following the given formula. Now we are coming to this table to calculate other steps. Now we are coming to this table, like we have these inputs, we have calculated this required other steps. You can look here from very near. Now we are coming back to our table for the central difference method. So here in central difference method we will have here steps. How many steps we have? Total we have 2999 steps. Okay, you can look here, like it exists many steps which are taken from the earthquake record. If you do not know how to get the earthquake record from one of the database, watch another tutorial which link is in the description box. The time in second, it is the time difference. Afterward we will have the ground acceleration. It is a ground acceleration, it is information has been taken from the earthquake record. Afterwards we will have the axial force or forces in kilonewton. This is mass multiplied by accelerations. After we will have, it is axial force for these and others. Okay, mass will be constant. Look to the constant, like when it have dollar sign, it will be constant, mass is the constant, and the ground acceleration is varying for each and every axial force. Then we will coming here from the right side to left. Okay, like we will have the displacement like one step below the normal UI, which is the normal. This one is to the minus side, and here is one side above, means it is the ith step for displacement. So means it is the ith step for displacement, means one step above the normal displacement UI plus 1, this one, and this is the displacement one step below the normal, which is UI minus 1, and this is the normal. I hope you understand. It is the normal displacement UI, and this is one step above the normal displacement, which is UI plus 1, and this is one step below the normal, which is UI minus 1. U means it is displacement in meter. This is one step below, minus, this is the normal, and here is one step for the displacement above, means the ith step plus 1 for the displacement. Ith 1 plus 1 and ith step minus 1, which is in downside. Now we have here the displacement, okay, which is 0. So, and here is also the displacement which are taken from above, means from the ith step plus 1, it will be like taken from here. This it is 0, and the next one will be taken from here. The same, this one will be taken from here, and the same, this one will be taken from one step above in ith plus 1 step from the displacement. Also same here, this is from here, and here we are coming to this side, it is 0, and here this will be taken from the UI displacement, and same here, it will be taken from here, this will be taken from here, and this will be taken from here. So it is very easy, not complicated. It is like, and this step will be taken from here, and same, this will be taken from here, and for this one, for example, this will be taken from here, not the same row, but it will be one row above it. So I will show you at the displacement UI plus 1, UI minus 1 from one of the manual calculations which I have done. Like you will be able to get some good information from that. Like we will have the UI displacement. This is UI plus. UIth means the ith step for the displacement plus ones. This is the ith step for the displacement minus 1, which is the negative side, means downside, and it is normal. UI minus ones, like it is will be 0 for each and every one. It is 0 0 0, and this displacement will be taken from UI, and this will be taken as from this ones. This will be taken from this, from this. Also same for UI. This will be 0, and this value will be taken from UI plus 1, 0. This one will be from this. Same, this will be from this, from this. So this is the manual calculations. Now we will come here to the axial force constant. It is the constant for axial force. So the P is the axial force, the normal axial force, which is here, the normal axial force, but it is the axial force constant, which is Pi. Axial force constant is Pi apostrophe, and this another constant was like K apostrophe, and this is the Pi apostrophe for axial force constant. Formula, we will calculate Pi or the axial force constant Pi, and Pi the normal axial force minus A constant, UI minus 1, which is the displacement for negative or downside, minus B constant multiplied by normal displacement, which I have explained. So by applying all the values in this formula, we will have the force constant here. Okay, you can just remember this. If you just look here, an axial sheet, velocity, then acceleration, then finally we will explain about the total acceleration. Here I will show you how to calculate the velocity. So this is the formula for velocity. UI velocity is equal to UI plus 1 displacement minus UI minus 1 divided by 2 multiplied by the time difference. It will be the velocity. For all these columns will be applied like the same formula. I have used UI plus 1 minus UI minus 1 divided by 2 multiply, it is time difference. Okay, the time difference is 0.01. Afterward enter. So it will be applied, and we will drag for the whole columns. It will be applied to the all points. Okay, so this is the velocity, meter per second. Now we are coming here to the accelerations. How to calculate the accelerations? Then look here to the velocity, UI double dot, and velocity single dot. Velocity, there is UI displacement 1 dot. In acceleration there is UI displacement double dot, 2 dots, double dot. That will be acceleration. Displacement minus 2UI plus UI minus 1 divided by the time difference square. So you will use this acceleration here to calculate these accelerations. Displacement, velocity and accelerations meter per second square. Now we will come here to the total accelerations. Now the total acceleration will be this acceleration which we have calculated, this accelerations plus the ground accelerations. Here the ground accelerations plus this accelerations. Then enter and drag for other columns as well. Okay, it will be applied. This ground accelerations plus this accelerations. Same here, ground accelerations, this acceleration, and it will be total. Same here as well. Now we have completed all the calculations for the central difference method. Now I will explain some information about the displacement versus time graph, velocity versus time, and total accelerations versus time. We will need this information also graphically. I will select insert, then I'm going to the scatter, select this one, then I'm coming here, select and go for select data, then I will add. I'm coming here series name as it is, but x axis will be the time difference. Coming here, I will do it manually, select all these information, so I will have all the information about the time difference. Then I will select also the displacement to show it is graph manually. It is for all the points up to end. You can just press the shortcut as well, you will reach to the final point. Then release it, then remove this series Y, come back to the displacement, come here, displacement is here, select this ones and go for all the points, then you will see it is graph. Release it, then press OK now and OK again. Now I am coming here to the previous point. Look here, it is our graph. I will do some adjustment. I will select this ones. It is our graph. It is displacement. It is displacement versus time. Displacement versus time. So I will just do some other information as well. Like now I'm coming here to do some elements about the primary horizontal and also another directions. It is the time, the displacement in meter, and also it is time. Okay, this is our graph, displacement versus time. So this is our graph about displacement versus time, and now we will do for velocity versus time and accelerations versus time. Now I'm coming here again, select here, go to insert, scatter, select this ones, put it here, select and go to here and come here again to add, select X, come here and go for the time difference, select, and now I'm coming here to select the X values, select here and go for all these columns about the time difference up to the last point. So it is up to last point, then I will select here for Y as well. I will remove this one, going up, then release, press OK and OK again, come here up and look for the graph about velocity versus time. So make sure do some adjustment, select this one and also change its color as well. Come here and select and change the color as well little bit. Then so it will be like the horizontal, and it will be velocity to the time which is 4 seconds. Okay, this is the velocity versus time. Velocity versus time. So it is velocity versus time graph. Now we will do accelerations versus time. Now I'm going here and scatter and also select the data will be add X about time, coming to the time, select for whole time, release, remove this value and select for the total acceleration. Coming here, select the total acceleration here, release and press OK and OK again. So come here to the graph and also so it is acceleration by second square, and also it is time and second, it is the versus time. So we have created all the graphs about displacement in time, this one, and velocity versus time, and also look here, when you select this graph, all the value will be displayed here. It is time difference and also velocity. Look here, velocity and the time difference. When you select this ones, it will be the total accelerations and the time difference t here. This is also for the accelerations versus time, the total accelerations versus time. So we have created the table for the central difference method. We have calculated all the values by considering the given informations, and we have also created the graphs for displacement versus time, velocity versus time, acceleration versus time, and show you all the related formulas. I hope this lecture will help you for the central difference method. Then last but not the least, subscribe our channel and press the bell icon for getting the very quick notifications. If you have any problem or suggestion, please write it down in the comment box. I will try to answer you as soon as possible. Then have a wonderful time.